Hi students, let's look at this question here which is on vectors, which was taken from one of the tutorial questions from ACJC, I believe. So given that L has an equation of r equals to 3, negative 4, 7, lambda is negative I, 3, negative 2, find the position vector of L closest to the point P on L, on the line L, closest to point P, hence show the shortest distance P on the line L is root 3, okay? So we want to find the position vector of, okay, great. So this case here, just draw it out. I think now you have a line L as such. So this is line L. Just draw a line L. I would suggest writing so this line L here, I'm going to write it out as L, R equals to 3, negative 4, 7. And this is lambda. Negative 1, 3, negative 2. Well, this is lambda equals the root value, right? So I like to write it in this vector, column vector form because it's easier. So this case here, once done, we're going to put a point on this. This is 3, negative 4, and 7. And then this line, this direction here will just be negative 1, 3, negative 2. Okay, this is L. So maybe just label this as L. Then after which we're going to put P, which is 0. So P is here. P is actually 0, 1, 2 here. And now we need 0, 1, 2. And essentially what we need now is a point, position vector of point on L such as closest to P. So closest to P will mean that we are going to look at this footer perpendicular here. Okay, so that's what we need to find. Alright, that's pretty okay. What we need now is essentially just put, so remember, because F is on the line equation, this lambda is like a housing address, okay? So every point on the line will have a different lambda. It's like you give me lambda equals 0, I know that it will correspond to this point here. Lambda equals to 1, maybe it's here. Lambda equals to negative 1, maybe it's here. I'm not sure, I'm just guessing. But so now the question now is, what is this lambda here? Because once we have the lambda, we can sub into the line equation and we can actually find the point there. Okay, so what we're going to do is actually for some lambda real value here, we know that OF would just be equals to 3, negative 4, 7 plus lambda negative 1, 3, minus 2. Okay, so for particular lambda, it will correspond to that point there. Then because I know that this is 90 degrees, what I can do is actually just PF dot with D, which is this direction here, direction vector here, will be 0. Okay, the direction of PF dot with D will be 0. So this case here, we take OF minus OP. And this would just be negative 1, 3, negative 2 equals to 0. Right? So just take OF. So now we have got 3, negative 4, 7. This is our OF plus lambda. Minus 1, 3, minus 2. Minus OP, which is actually 0. 1, 2. And that will be negative 1, 3, negative 2 equals to 0. Alright. Then what we're going to do is just dot them. So before that, I'm just going to 3 minus 0 will be 3. Minus 4 minus 1 will be minus 5. 7 minus 2 will be 5. This will be lambda. Minus 1, 3, minus 2. And then I'm just going to dot this up. Okay. Typically, this is how I dot it. Just dot this. This vector, this column vector dot with this. Then that will give me negative 3 minus 5, negative 15 minus 10. Then plus lambda. Then we're going to dot the other one, which is actually dotting this here. Then this will be 1 plus 9 plus 4 equals 0. Okay, that's about it. So key in calculator, I think you'll get a lambda there. The lambda there would be negative 3, negative 15 minus 10. That will be 28. So this is 14 equals to 28. So lambda 28 divided by 14, that will give us 2. Okay, so if lambda is 2, we could find OF then, which is actually OF, which is the point. So hence OF, OF is equals to, just sub back lambda into the line equation here. 3, negative 4, 7. So 3, negative 4, 7 plus 2, negative 1, 3, and minus 2. Okay, that's about it. Key in calculator will give us, this is 1, 6, this is 2, this is 3. 1, 2, 3. Such a nice number. Alright, so we got the, what do they want? They want the vector, position vector. So hence the position vector is this. Okay. This position vector of OF. That's about it. Great. So that's the photoperpendicular here. Hence, so once we're done, we find F already. Shortest distance of P to line L is √3. So this case here, shortest distance from P to line L. So hence, shortest distance from P to L, to line L, that will be, there will be just the distance of PF, right? Because that's the photoperpendicular is equals to modulus of PF here. There you go. So what you're going to do is actually just take OF, which is 1, 2, 3, minus of OP, which is actually that will be 0, 1, 2. Now this question here is a show, so I think by showing you, like, you already know that yeah, there you go, your answer will be correct here. So once it's correct, then it's quite reassuring. So it's √3 units. Okay, so that's about it. So I think the shortest distance done. That's how you do the first part.